Hi there, welcome to episode 32 of the ChessTDD series. Pardon any background noises you might hear. I'm sort of at a quiet hideaway for the weekend, and there's a wind chime outside in the background, and then there is also a fire by which I'm recording this, so my apologies in advance if it's not kind of my normal audio sound. What I'm doing last time is just recreating the test that, if you'll recall, I deleted at the end so that I could check in with everything passing. And this test is the one where I take this same board setup, and I'm going to assert that basically the black king at the other end of the board should be able to move anywhere that you would expect a king with no pieces around it to be able to move. So specifically, that's going to be these squares at 3-8, 3-7, 4-7, 5-7, and 5-8. And it took me a minute to get back on track with that. Also, fair warning here, this is an episode that, like the last one, goes pretty long because whereas last one was kind of The Empire Strikes Back, this is Return of the Jedi. It's a, adventure, but this one has a happy ending, unlike the last one. Hoping to get them back down to the 20-minute or so range going forward, but as I am sure you can all relate, it's not always a specifically nicely segmented thing when you're tracking down bugs the way it generally is when you're implementing new features without issues. So at some point here, I went and closed these windows. And today I actually have the benefit of having just recorded the code for this, so I kind of remember what I was doing. I went and closed everything and wanted to kind of start fresh with a fresh outlook on the problem, I should say. So what I tried to do in this episode, maybe more so than others, is get away from using the debugger unless it was absolutely necessary. I wanted to use the continuous testing tool a little more to trace the path through the application, and then strategic asserts to kind of figure out what was going on, especially here where I'm using a lot of link and deferred execution. Stepping through with the debugger gets a little awkward because I've got these interior lambda expressions and, like I said, the deferred execution. So this is not an especially productive episode from the sense of getting more code and acceptance tests and all that written, but we will wind up here with a few new tests at the end, sort of at different levels of specificity in the application. So what you're watching me do right now is kind of try to wrap my head around what's going wrong. Where we left off last time was that all possible moves seem to be going well, but these two pieces of filtration, I guess, at the end here, where I'm refining all possible moves based on restrictions, that's where we're encountering a problem. So one of the techniques that you'll see me employ here that doesn't involve the debugger is this kind of binary search concept. So I've got two different things going on there. So I should mention it, with NCrunch, I've restricted it to only show me this test, so that's what's going red and green. So what I did there was a binary search. There are these two restrictive conditions. I commented one out, still red, commented the other one out, saw that it went green. So that tells me, hey, it's in this is blocked. That's what's causing the problem. Okay, so we've now traced the problem, it appears, into this is blocked method, which is a private method. So it might get a little bit interesting to go about testing that. But what I'm going to do here is go into the area of the test code, and this is the unit test now. We're out away from the acceptance tests, and I'm going to think about writing something. Let me recreate this same scenario with the more specified code under question in question with the unit tests. So now that I'm looking at what's going on here, I have this hypothesis that maybe we're not really we're not getting this concept of blocking correctly. So let's recreate it with a narrower scope. And I'm trying to remember exactly what test I wrote here. I think I set up a whole different context, and it was basically, let's set up just kind of one side of the chessboard. So let's set up a chessboard without black pieces, and then we'll just add that black king over there on the end, and that will get us kind of back to where we started here with the acceptance test. So let's recreate, and this is a common thing when you're doing outside-in TDD, or when you're kind of walking the line between acceptance tests and unit tests, that you'll sort of kind of move up and down the levels of abstraction. It's good to find kind of production-ish scenarios and then recreate them more locally so you have more control and there's less superfluous setup going on to reproduce your problem. So I'm taking and I'm going against my normal practice of not copying and pasting code. I'd like to tell you that's for instructional purposes, but it's really just kind of a mistake. I am not perfect by any stretch. As I've always said, I try to force myself to type it out and feel that pain. Just like anyone else, sometimes I kind of forget, especially these days. I'm not writing a lot of code right at the moment. I'm hoping to change that soon. So you kind of revert to doing things that aren't great. Wait till you see how I butcher string.format later. That'll tell you how little code I'm writing these days. Okay, so what I'm doing here is I'm just going to take this piece that's set up with only the white pieces, and I'm going to add this black king here to where we have it in the acceptance test. In retrospect, and then what I decided to do here was why not just make this a setup context? If I'm using this a lot in the acceptance test, I might later have further things with this particular board setup where I want to come back in here and write different or other tests as well. So I just moved that into the setup and changed the name of the test class. Another thing that occurs to me is that I don't actually necessarily need these white pawns, but I left them in because again, it's the same sort of logic that's duplicating the acceptance test scenario. Okay, so now I am in fact reproducing the problem. So I see here that it's nothing. And so here's a thing to mention too. It might have been, in that sort of beastly method I still need to go back and refactor in the acceptance test setup. It might have been that I was not setting up the board properly. So this is actually, it seems kind of trivial, but there's an important thing going on here. Since I'm reproducing it completely in unit tests and with nothing to do with spec flow, I know that this is not a setup problem with how I was using spec flow and passing the context around or anything. So that is something of significance. Now I know that for sure I'm looking in the production code for this bug. Okay, so now I'm going to take a look in this isBlocked method and try to use some of these same principles that I've been using to track down what's wrong. So there's a few different things going on in this method. There's I'm creating this path maker, so that could be, am I getting the right path? I'm looking for spaces along the path from the path maker. Then I'm looking for the last space, and then I'm doing a bunch of filtering, or at least two pieces of filtering. So the first thing I'm going to do is a technique here where I'm going to, instead of returning this, I'm going to create this local Boolean and then throw an exception if it winds up being blocked. So what I know is I've got this black king surrounded by nothing, so nothing should be blocked. And because of this, what I was doing was returning filtering on an enumerable with deferred execution. So stepping through in the debugger was going to get weird. So what I want to do is sort of whip out of here at the point where there I am butchering string.format. I just completely spaced as I was typing this. I don't know if other languages, or I'm thinking back to C or something. I don't remember what, but Then I realized what I was doing after a minute. Anyway, what I want to do is kind of whip out of the call stack here at the point where I actually get something that's blocked. Because as you can see with NCrunch, I only have the covering failing test here active. So I can mouse over this and see in the exception message, okay, so for what destination coordinate is this being considered blocked? That's a no-no. We shouldn't be blocked anywhere. It's a king with nothing around it. How could anything be blocked? So what I see is, oh, it's for this this move where the destination is 3/8. So in essence, that is moving the king one space to the left if you're looking at the board. Now, that doesn't in and of itself tell me a whole lot, but it does tell me that I might want to look in more detail here. I've got another thought about kind of a binary search. So I'm saying, are there any spaces along the path where a friendly piece exists? Or are there any spaces along the path where this piece exists? And I don't remember what I was driving at with that last bit of code there. And that's actually a problem. I should endeavor to make this a little bit more readable. I don't think it's terrible. Up till the that compound Boolean expression, I have a pretty good idea of what's going on. But as you can see here with a struggle, I'll have to. So thinking that the problem here is with looking for certain kinds of spaces along the path, I started to extract out a method, and I got it wrong because I think my brain didn't properly process the number of opening closing parentheses here. So I thought that this was all one big any clause. So spaces along the path dot any, and then a lot of complicated stuff. But in reality, it's spaces along the path dot any, and then or spaces along the path dot any. So two different kinds of spaces along the path I'm looking for. One where there maybe is a friendly piece, and another where there is a piece and space. I don't remember what I was driving at there, which tells me that I have not done a sufficiently good job of refactoring this. Maybe it's on my list. I don't really recall. So I guess I'm trying to think. I believe does piece exist at tells me there's an enemy piece there since it's not a friendly piece. I have a method for that. I just cannot remember why I would say and the space is not equal to last space. I get it. The idea being that this would be a valid capture. So mystery solved in my head, if nowhere else. Now, what I did figure out, I think by this point I've sort of babbled embarrassingly to cover that faux pas in writing the method. So at this point, when coding, I figured out what was really going on. So now I'm doing my binary search technique again here and saying, okay, this is blocked is clearly the problem. Is it that there's a friendly piece existing, or is it this other thing? Okay, so does friendly piece exist at? If I comment that out, I'm getting the passing test, which is what I should have. So that tells me now we have another data point here. Something is going wrong and does friendly piece exist at? So I'm getting the piece, and then did I go back? I think I went back and did a bunch of undos. Because now I don't want all this temporary cruft in here creating problems. What I want to do is now go up to this other method. So let's put this thing back. Now we've gotten all the utility out of this we can. We see that that's not where the problem lies per se. It's now in this other method I want to look at. So what I'm doing here is the same thing. I'm going to introduce this Boolean condition and then just kind of go with the same playbook and throw an exception. So let's create a Boolean called does friendly piece exist? And then if it does, let's throw an exception. because what I really want to know is with this origin and destination coordinate, why, always keeping in mind what's actually going on here, why with a king piece with nothing around it is does something in this origin destination path trigger friendly piece? That makes no sense. So let's find out what the origin and destination are where this is happening, at least once I fix my syntax errors. Man, I tell you, it's really a thing coding for the world to see, because when I narrate back over, it's just everybody's seeing every stupid thing I do while I'm writing code. But, such is life. If you ever do randori coding exercises, group or mob programming, you get pretty used to this. It's humbling and also reassuring because you see that literally everybody else, even the people you think are the most amazing programmers on earth, make dumb mistakes like this. So now I'm actually kicking into the debugger because I want to understand more about what these two things are at runtime, and it seems like a lot of overhead at this point for me to do it by writing a bunch of extra precondition asserts. Now, the interesting thing that's happening here is that origin and destination are the same. So this is going to cause me to shift gears here. So let me tell you about that in a second. Okay, sorry about that. I took a quick audio break because there was a train coming by. So now I'm seeing an interesting thing, which is that origin and destination are the same. And we can kind of just reason about this from the perspective of what's going on in this board class. Why would we be in a scenario where we were seeing whether, it's a degenerative condition to say, I have an origin and destination coordinate that are the same, and is that path blocked? It's not a path. Of course it's blocked. There's a piece there. So that is something we need to look into. So we're really kind of tracking this down. So in is blocked, I want to see now, do we get into a situation where is blocked is called with the same origin and destination, or is that something that's happening with this path maker concept I have? So I'm going to, I believe, set a breakpoint or do something in here in order to figure out what's going on there. And I don't remember off the top what I did. I do remember that because I had forgotten to sort of clean up my tracer bullet code, that I have a whole lot of failing tests here. I had a brief moment of panic where I thought, uh-oh, am I going to have to blow this up, go and revert all the code to the way it was last on GitHub and start all over? But it turns out no. I figured out after a second that, oh yeah, there was this place where I was throwing an exception. So let's undo until we get rid of this stuff, because I don't need that breadcrumb anymore, and it's just confusing matters. And in fact, I don't need any of this stuff because the does friendly piece exist at method turns out not to be a problem. What is the problem is the fact that it's getting the same coordinate as the origin and destination. So I think now it's probably time. I started to get suspicious at this point of this path maker. And I think what I was doing was trying to get into its constructor and find covering tests. I want to see. Okay, so this is getting weird. Let's go find tests. And boy, there are a lot of tests that cover this. So that's probably kind of a good thing. Here are the reasonably written ones that are failing. And we're hoping to make green by the end of this. And so here are the only first class tests that I've written about the path maker. So what I'm going to do is write another one. And I like the position I'm in here where I've narrowed things down. So I'm just going to start writing things that should be true, but things for which I have not made an explicit test. So one of the things I'm saying is, hey, maybe the problem is I'm invoking this degenerative condition, and what should happen, I would think, is if I call this path maker with the same origin and destination, I think a nice way to handle that, well, first of all, a good way to handle that could be to throw an exception to say, hey, dummy, you're doing this. But given everything I'm doing with sort of like mathematically complicated stuff, I also kind of, in this case, like to represent that as just an empty collection. So that lets me, if I'm doing some refactoring or compacting things with link, and maybe there's a case where I could hit this and all I want is for nothing to be added to the path, for instance. So my first suspicion is probably well-founded, but turns out not to be the problem. I am handling this properly already, but I'm going to leave this test here because that's probably what it ought to do. If I pass in origin and destination is the same, I get back a path that doesn't exist because there is no path. That's nonsense. So the next thing is, if I am going to go right next door, am I moving from 4-8 back to 3-8 only to be getting like a whole bunch of superfluous moves? Like maybe it's giving me moves all the way to 1-8. So I want to check to make sure that that's not the case. So here I'm going to move from 4-8 to 4-7, which I seem to recall is one of the places we have a problem with this filtration anyway. So I'm going to invoke another path maker on this specific thing where the origin is 4-8 and the destination is 4-7. And then I want to assert that that the path I get back consists only of the point 4-7 because that's the only path. So I mess up this predicate here for a minute, and then I get it right, and I discover something interesting, which is that I get a red test where I'm not expecting. That is really going to be good because we have gotten as narrow as possible. This pathmaker is a fairly tiny class, and if we're getting red here, that indicates, hey, we found where this bug is. So it could have been before in the acceptance tests with, me fumbling my way around in spec flow, or it could have been somewhere in the board logic or maybe the king piece logic. But now we're drilling down and we're really getting specific with pathmaker. And, it's not unique to TDD or to any particular approach. This is what you do when you're looking for bugs. You try to narrow the field as much as you can until you eventually isolate the point where it's happening. Okay, so I am saying give me the first move, which, by the way, should be the only move along this path, and that should be 4-7. Now, here's a weird thing. So there is a path, and the move that's coming back is 4-8. So what I'm actually getting back is that the only move on this path is the origin, and that doesn't make any sense. This should be a pretty straightforward case. When I'm getting the possible moves from here, it should just be that one destination. Oops. So what's going on here? I looked at this for a minute. You can see me kind of staring at that. And then something occurred to me as I was looking at this. So I'm getting... sorry, there's a training, and I'm just going to let it go this time. I don't know how many different directions the trains can come from. I would think too. Anyway, what I was looking at here was this max or most and least. Basically, what I was trying to do was kind of, and I think I did this a number of episodes again, squash these conditions so where it didn't really matter in which direction I was going. So if I was moving a piece from 4-8 all the way back to 4-1 or going from 4-1 to 4-8, I wanted to kind of use an absolute value sort of construct to make that symmetrical. And what I started to think about was, if I'm going from 4-8 to 4-7, that's not the same thing as going from 4-7 to 4-8. There shouldn't be the same path. So I think what I need to do here is see if, and I had this aha moment where I realized all of these test cases I was writing were from the white side of the board, and everything seemed to be great. Maybe the problem here is in my logic around these paths, where I'm getting caught up in treating, I'm trying to treat everything so uniformly that I'm actually getting things backwards here. And then I started to look at this and think about it in my head. And like, if you look at this, least in this 8-7 scenario, least is going to be 7, most is going to be 8. So I'm doing this enumerable range that starts at least plus 1, which is going to be 8. And then it goes for most minus least, which is 1 piece. So I'm starting at 8, and then I'm going to look at 9, which is off the board anyway. So this doesn't work. This logic doesn't make sense for moving back towards me on the chessboard. Turns out I really can't condense this logic. It's not the same for moving in the two different directions. And you'll see why as I fix this. So in the one case, I'm going to say let's go back to if the origin is less than the destination, then I am going to start at the origin plus 1. But on the other hand, if the origin is greater than the destination, I'm just going to start at origin. Now, I don't think that I wind up fixing everything, but I fix this acceptance test case here through this logic. So I think what needs to happen in general is that I just need to treat both horizontally and vertically the moves as separate kind of beasts. And especially if I'm going to use this enumerable.range thing, enumerable.range assumes that you're kind of moving along in a positive direction. That might not be the best tool for the job here. So in the case of moving towards, and I don't remember if I fix this, I'll probably want to start off with a confirming test next time. But in the case of the y coordinates to check, when I'm moving backwards, so to speak, when I'm moving from 8 back, I want to start with my destination, and then I want to move along. Let's see, destination minus origin. So for that number of pieces I want to move along, I believe this winds up going green, and I'm a little suspicious of it in retrospect. But yeah, it's not green yet because I have a non-compiling by virtue of not returning anything from the fall-through clause. But once I do, things go green. And now as I'm looking at this, I'm not sure if it'll work specifically just for this case that I'm looking at here, or if it will work for arbitrarily larger moves backward along the board. I'm hoping it does, because a whole lot of tests went green when I finally got this fix into place, but should probably confirm it later. So I'm saying in the case of an origin that's greater than destination, what I want to do is take the range starting at the coordinate in question and working backward. I think, well, we'll find out for sure next time. Maybe you can see it right off the top, whereas I can't. I am certainly not necessarily the best off-the-cuff reasoner on earth about complicated, off-by-one type things. I think I maybe can hold my own, but it is entirely possible that someone out there is watching and cringing and saying you're going to stumble on a bug next time when you try to move a rook here. But at any rate, getting towards the end of this episode here, I can offer a little bit of a spoiler as I work through what's going on here, which is that this does get everything to go green. So once I fix up the logic to be similar to the vertical path spaces, then we have all of our problems fixed, and there is much rejoicing. Now again, it might not be fixing the world, but we get to green here, which is good enough for a commit. The acceptance tests go to passing. All of the unit tests in the code base remain passing once I get this fixed. And, at any given point, that's really all we can ask for. You're that way making sure, this is really the core theme of TDD, that you're getting a little better, and you're doing so without regressions. So certainly there are non-implemented things going on, and probably other bugs lurking out there. But we know that there is a fix, at least for the one exposed by this acceptance test, and that's powerful. Because now what we know is, at least in that scenario where you've got the white side of the board populated and there's just this black king floating around up there, all of the black king's moves from that position are going to be correct, even if we haven't fixed every bug on Earth. So I'm going to move that over, and then I'm going to add something here, because now this Pathfinder is getting kind of, not awesome. So I'm going to say, like, let's refactor the new stuff that we've done in Pathfinder. It's a little bit nasty. And that'll be a thing that I'm going to move up. I'm going to put this as not quite as important at the moment as the work that I'm doing with getting the spec flow tests prettier. Because number one, that's new to me. And number two, we're at the phase where we're writing a lot of acceptance tests. So we got to get that kind of squared away so we can cover more ground with the acceptance tests. And then as long as I was kind of way over the normal time here anyway, I don't remember why I started closing all these class files. Neurosis of mine, I guess. But what I wanted to do was go and show you that I was kicking this on up to GitHub as ChessTDD32. So that is a commit that's on there and synced. If you want to go check it out, please feel free to subscribe, watch, etc. And with that, I am done for the episode, and I will see you next time. Thanks for watching.